of that, so all of these are put in some sort of an order. Okay, they need to be put in some sort of an order. So for converting this ordinal attribute to what is known as the binary attribute, okay, we use the technique called as binarization. Okay, so we use the technique called as what? Binarization. That is what you are trying to study now. This is what we are trying to study as of now. Okay, so for doing this, what are the steps involved? What are the things that need to be kept in mind? That is where you can see very clearly the steps here. It says if there are m categorical values, okay, then we are going to uniquely assign each original value to an integer value interval is there saying. How many values do you need to sort of assign? You need to assign from 0 up to m minus 1. Okay, so the first step is with regard to here is I'm going to assign all of this an integer value. How that is done? Okay, so I'm going to write that entire thing right here again. Awful. Again, you have nothing but poor. You have okay. See this, all of these things, right? It is not there in your syllabus. You just have to know the example. Many people, what they do, they buy at the example. That should not be the case. Okay, should understand this. But when you start studying data science in detail, binarization will come. Don't see the way I'm drawing the table and all. Very difficult to draw. Okay, neatly and all. So I need to sort of assign an integer value for this, for each and one of it, right? So what is the integer value I'll assign? I'll assign right from 0. It has to start. So it starts from 0, 1, 2, 3, and 4. Okay, these are the integer values that are assigned to each one of it. So the first step is done. So you can see very clearly the first step is all done. Next, we need to convert each of these m integers to a binary number. So we need to convert this entire whatever the integer value I am assigned to a binary number. Okay, so how many binary numbers we need to take? Thus, the length we need to take. That needs to be sort of understood. For that, we use what is known as this formula. N is equal to log 2 to the base m. Okay. For that, how you figure out what is the number of attributes you need to design, or what is the length of a binary number you need to design? See, binary number can be written as just 0. If I want to represent 1, how can I represent? I can just write 1. So what is the other way of writing? I can write this as 0, 0. I can write this 1 as 0, 1. Correct? Okay, I can represent like this, or I can write this as 0, 0, 0. I can write this as 0, 1. What's the next thing? 0. No, 0, 0, 1. Like this. I need to figure out what is the length I need to represent. This length, right? This, what is the amount of length I need to represent? This length needs to be figured out. For that, there is a formula. What is the formula they have given? They have given a very simplest of formula called n is equal to log 2 to the base m. Okay, log 2 to the base m is a formula which they have sort of given. So what needs to be done with regard to it? This n is representing number of binary digits. Correct? Okay, this number represents number of binary digits. Log 2 to the base m. What is the number of m? M is nothing but the number of integers you are representing. Till where it has gone? Till up to 4, right? It has gone up to right till 4. So log 2 here. This value is somewhere around 2.32 something you get, which is almost okay. You need to take the next value. What is the next value to it? 3. Okay. So you are going to take the 3 values, okay, which is very much next to the value called 3. So number of values that the binary digits which you are going to represent is in terms of 3. 3 values you are going to represent. Okay, 3 values you need to put into perspective. How that is done for this table? That is done like this. Okay, so just look into this. The way I'm trying to do this, the next column what you see right here is in terms of the number of digits you are trying to represent. It clearly says please represent these integer values in 3 binary digits. So I need to have what is known as 3 representations for it. Okay, I'll call them as x1, x2, and x3. Okay, x1, x2, x3 is what I call. So if I want to represent this entire all these values in terms of three binary digits, so 0 will obviously become 0, 0, 0, right? Very clear. Okay. Then the next one. This is with regard to C. What is the meaning of this? Probably you must be knowing all these truth tables, everything and all by now. Okay. So this is what? This is in terms of what? This is in terms of 2 to the power of what? 0. Okay. This is 2 to the power of 1. This is 2 to the power of 2. Like that. Probably you must be knowing all this by now. Okay. So this is with regard to 2 to the power of 0. So if I want to represent 1, what will be the values of it? The value can be represented like this. What? 0, 0, 1. Check whether it is represented. This is all these things is nothing but the binary representation of my numbers which are found of what? Binary representation of these values. So this is something that you need to keep in mind. Okay, this is nothing but a binary representation. So see these values 0, 0, 1. Then the next one is with regard to 0, 1, 0. Correct? Because the value is 2, I represented that in terms of here. Then the 3 value. 3 should be represented as 0, 1, 1. Okay. Then 4. 4 should be represented in terms of 1, 0, 0. Okay. 4 represented like this. This is the binary representation. Now the problem. What is the problem? See, what is my purpose all of you? My purpose is to say, see these things what I'm saying, my original intentions we should not forget. My original intention say, I need to represent this awful. Okay. See, I need to represent this awful in terms of binary values. Okay, I'll say awful, please assign 0. Okay, poor, assign 1. Good, assign, okay, 2 like this. Then good, sorry, okay, assign 1 like this. Then good, I need to assign. Now the problem here is these two, this place. This place, I am not able to do it uniquely. Why I am not able to do uniquely? You can see very clearly all of these are zeros, so not a problem. Here only one is 0, 1 that is coming in this place, so not a problem. Here 1 is coming right here, not a problem. Here also 1 is coming in only in this place, so it is here also not a problem. But when you see this, the 1 is coming in 2 places, what you see here. Okay, it is very much coming in 2 places, so I am not able to uniquely represent. Okay, uniquely representation is not at all done. No uniquely representation is done here, so this needs to be modified. How you can modify this? Okay, how you can modify this such that you can uniquely represent this? Just by making sure that you say this is 1, 2, 3 values. If you sort of increase this number of values representation, then probably you can easily represent what is known as this unique representation or unique binary representation of this can be easily done. How that is done? Okay, before we move into that, let's look into our slides. Are we doing the slides correctly? Okay, if there are m categorical values, we need to put them in such a way that right from 0 to m minus 1. So 0 to m minus 1 means there are 5 values, so 0 to 4. Done. Then we did convert each of these m integers to binary number. So that also we did. How? Based on this one, right? If n is equal to binary digits are required to represent the binary digits using n attributes. What is that value we got? We got, it is equal to 3. Okay. So we used that, we represented everything. The next one, we did this. See this? The same old table. I'm not doing anything extra. Same old thing only we are going to. Okay. Categorical value is here. Integer value 0 up to 4 also we did it. Then x1, x2, x3 also we did it. Okay, no issues with regard to it. Now the next part, I told you very clearly that we need to represent into the 5 value table or a 5 value representation. That can be done like this. Okay, that can be done like this. How it is all done? I can uniquely represent that 1, 2, 3, 4, 5 like this by assigning what? Conversion of categorical attribute to the 5 asymmetric values, asymmetric binary attributes like this. Here it becomes very easier for me. Okay, so you can see this integer value 0, right? That is represented by my x1. You can see very clearly here. Okay, this is with regard to 3, this is with regard to 5. Now each and every value here has only one value. Each and every row has only one unique value, which is 1. So this can be easily used for figuring out my categorical values, for knowing what is a way. So now when I say awful, I know x1. When I say poor, it is x2. When I say okay, it is nothing but x3. Like this, I can easily do it. And what is asymmetric binary attributes? Only non-zero values become important. Here, what is non-zero values? The one value. What is that one representing? Awful, poor, okay, good, great, like that. Okay. There is no need for you to know all these things. You can just write one example and then leave it for data mining, data warehousing for 6M. But probably it may help you somewhere, down the line when you study a lot of subjects related to data science in depth. In-depth analysis, when you start doing it, probably this will become a lot more easier, a lot more, what you call interest. Okay, that should not be sort of missed out. Okay, very important for you to know this. Okay, so this was with regard to what? Binarization and discretization. So let's go into the last part of it. What is the last part of data preprocessing? The variable transformation. What is this? We are going to transform. You can see very clearly it refers to the transformation that is applied to the values of a variable. So we're basically transferring a particular variable into something else. The last data pre-processing technique. First one example is we are going to convert our data on a floating point value to an absolute value. One of an example. Or in that there are two types. First type is the simple functions. What is simple functions? A simple mathematical function is applied to each value individually. How? If x is a variable, okay, then examples of transformations include what? You can easily transform that x variable into various things. What are the various things? E to the power of x, that is one way of doing it. Okay, 1 divided by x, log x, sin x, like that. So x value is transformed into various other types. Okay, that's why it's called as variable transformation. Various other types I am trying to transfer the same old x value. Okay, the next thing you check. What's the next thing? Next thing is normalization, or also known as standardization. What is that? The goal is to make the entire set of values have a particular property. That's why we call it as normalization, right? You need to normalize the values, or you need to make sure that all the values are having same sort of a property or some sort of a property which is very much unique. Okay, that is something that you got to keep in mind. Okay, that is what you got to keep in mind. Okay, what is that? The traditional example is that of standardizing a variable in statistics. I've given this thing probably for you to go for more in-depth analysis of it. If you got time, probably not now, maybe after internals and all, you could always go there and see what is that standardizing a variable is. When you type that in YouTube or in Google, you get so many examples, so big examples. This again, it all depends on your interest to study data science in depth. For that, all these mathematical functions, mathematical way of doing these things should be known. Okay, some people may argue that everything when it is done using computers, algorithms and all, why do you need to be strong in mathematics? For that to be applied in form of a program, algorithm, or using of computer and all, you need to be good enough to write that in mathematical form. Then that can be applied in form of an algorithm very easily, right? So your statistics, your mathematical functions, your mathematical logic should be very good when in terms of if you want to go more into your data science and all. Okay, so only always say please refer some of your courses when it comes to NPTEL and all with regard to data science, machine learning, for you to get more knowledge of it. Faculties will limit themselves, especially during that online thing, that too with all this pandemic happening, they will limit everything to VTU, because again, so many, you never know who's in what sort of a problem. Okay, Every household has one or two persons who are affected by this. Okay, maybe their relative, maybe their distant relative, somewhere like that. Okay, so got to put them into consideration. People will limit themselves. Make sure that you people are learning on your own. Okay, so yeah, what is normalization? Normalization refers to what? Various techniques you need to adjust to the differences among attributes in terms of what? Frequency, occurrence, means, variance, range, everything. Unless we study an example, probably you will not be able to sort of know that. Okay, what is an example you can take? See, when you take your class example, when you take your own class example, each and every person has a different sort of results. I want to normalize that. What I do? I take a mean. Okay, if I take a mean, I know the mean of your class in terms of management and entrepreneurship was 66. So I'll say majority of your class is almost between 60 and 70. Then majority of you people will be falling into that place. Okay, I'm normalizing it. Of course, there will be people who are not falling into that place. Okay, that is known as, what do you call it, as outliers. I'll call them as outliers. So those people will not fall into that place. Okay, so this is all these things for what is known as the data pre-processing task. I think it was so many tasks which we studied. If you want to give a perspective of how many we studied, so let's go to that the slide that we were talking about. The where did we start and how many were there? Okay, this was the slide I was talking about. See, we start with aggregations, then sampling, dimensionality reduction, feature subset selection, feature creation, discretization and binarization, then variable transformation. 7 tasks. All the 7 need to be kept in mind. All the 7 need to be studied very well for you to make sure that you get the 10 marks. The 10 mark question, standard 10 mark question. So make sure that you people are sort of knowing to that. Okay. So the last topic among this very big module called this module 2 is measure of similarity and dissimilarity. Okay, what is that measure of similarity and dissimilarity? Similarity and dissimilarity is important because why? Because they are used by many data mining tasks such as clustering, classification, anomaly detection. To do all these things now, we need to know to what extent the data values are similar or dissimilar. Okay, for that, what is the thing we use? What we use known as proximity. What meaning of proximity? To what extent the values are almost similar. See, why your class average is coming to around 66? Because majority of you fall in that bracket between 60 and 70. Of course, it would have been a better average if few people would have been, few people would have got even more better marks. Okay, and there are few people whom you need to thank who got more than got around 85, 90 and all. Out of 100, I'm talking, of course. Okay, so if you figure out that in form of a graph, so the proximity between data objects, proximity between the data results are somewhat less. Okay, proximity is somewhat less because there's variance between things. But if you take that majority between 60 70, the proximity is very much very much close, right? So what is the proximity is used to refer either for simple similarity and dissimilarity. Similarity between two objects is what? Numerical measure a degree of 2 between the two objects, to what extent they are alike. Okay, similarities are higher for pairs of objects that are more alike. Okay, if two things are